Okay, so this is a very quick video to describe the Euler method for system identification for the two-cart system. You can see that here I have uh, loaded the data and trimmed it, all right? And the reason to do that is we want to make sure the value is going to be centered around 0. I'll double check that at the very end of the video. The way that I have my value saved here, I need to define a time and value vector. Chances are you already have these saved as variables. Okay, so you'll load and then trim your data. All right, then I want you to set your timing. Your final time, probably 60 seconds, is here. The more steps, the more accurate your approximation will be. And then you need to make a timing vector to be able to plot your Euler approximation over the original. All right, let's initialize omega to be 0, and let's make theta be equal to the values of data here, and specifically the same thing as x up there. And then we need to set some parameters for Euler. There's a dry friction coefficient value c, which we'll want to find, and then k and j. And actually, these can stay. In fact, the j is similar in Euler to the m in Runge-Kutta, and I think it should be probably around 0.55 for your experiment. And k is, of course, 2 times 15. That's the springs. All right, and then there's the Euler approximation for loop. You can actually see this from the lab handout, and you would do the data plotting. And so basically, these two parameters are the ones that you need to change in order to get this very close to the actual value. So let's run it and take a look. All right, you can see that, in fact, this data is centered around 0. That's perfect. That's what we're looking for. So make sure that that makes sense. All right, and then you can see that it starts out pretty close, but by the end, there's some issues. And ideally, what you do is spend some time iterating through values of C and MF to try to get it as close as possible. But in the end, what you'll see is that this is much less effective than some of the MATLAB versions, specifically the prediction error method.